the lecture contents. Okay, so ladies and gentlemen, we have gone through a set of these best practices. We talked quite a bit last time about a risk-driven incremental delivery, but particularly continuous integration. I'd like to talk about a few more of these. One is this notion of risk-driven testing. The projects this term are projects where testing needs to be front and center. I'm asking you to apply test-driven development. Make the tests first. Make it run. Make code that will successfully. So at first the test should fail, right? Then you write code that will run and pass the tests, and then you'll do some refactoring often to improve the code. Okay. I'm not going to be a real stickler. There are some people who do test-driven development who argue that you need to be policing yourself so you don't put in any components of that code unless there's a test that fails that demands them. There's some test that won't work without that piece being added. Why would you do that? That sounds perverse. Like, don't do any development unless there's a test that demands it.
So that you're not making more than you have to?
Yeah, that's right. So you don't want to be gold plating the code, so that's part of it. What else, though? What else does it make sure gets in place?
Make sure your test is actually testing something?
Yeah, make sure that the test is actually testing something meaningful, something significant that will fail unless there's corresponding logic in place. So that's good. And at a most basic level, make sure that your tests are up to snuff. That you have tests that are sufficiently large to really exercise the different functions, the different features of your code, right? Because if you're not going to add to the code, except the test in place, and the code needs something, that points you to, okay, let's get this test in place. Well, that's a good thing to be guiding yourself on as a general principle. I'm not going to police that. I'm not going to say, I'm not going to scrutinize things and say, where's the test for this feature? Although, okay, maybe I won't sneer like that. Okay, but this whole notion of test-driven development is an important one because the test should not be an afterthought that are kind of put in for the deliverables. You should try to get them in place because they help you think through the logic of the code. They help you think through what is it that this code has to do? What does it has to guarantee? What does it has to accomplish? And lets you put that into place. Okay? So test-driven development is very important here. And I might have a full lecture on that at some point here during the term. But I want to talk about other features that are required in the testing context that are expected of you. Because much of these slides are about that. One I'm looking for you to provide me. So one thing I've spoken about, it's kind of stuck in here at the first one for no privileged reason, is I want to make sure that the testers and the team get code as soon as possible. So I did request a freeze date. Freeze early, a few days ahead, so testers can get code. That doesn't mean the code can't have bug fixes in it, fix oversights and so on, but it should be basically feature complete so the testers can do meaningful testing on it. Because if you don't test it, I will. If you test it, I will also test it. But we will make sure that it is tested. You need to design for testability. Now, that sounds all, motherhood and apple pie. But the fact is, it's really easy to miss, ladies and gentlemen. You build your code partly to facilitate testing. That's one of the things you're aiming at. And there's a lot of principles for this. What's one principle that, generally speaking, is sort of a good thing with your code And it also very much impacts testability. Can anyone say? Say you're doing a 3-tier web app. It involves some database side operations. It involves some business logic, some sort of general logic for how the application needs to work to deliver the value in its area of application. And it includes some UI stuff. What's something you don't want to do that will really adversely impact testability? Oh, I would hope that this would have come out in some of your earlier classes. I would have hoped that it would come out in 270 and 370. Ladies and gentlemen, we have as a strong need in those cases, and in many other cases, the need for what's called separation, can anyone finish it? Of concerns. Yeah. This helps us write the code in a meaningful way, because you have different people working on the database layer, different people working on the business logic, different people on the UI. It facilitates decomposition into different technologies. But it also supports testability. If they're tied together in a hairball, ladies and gentlemen, it's hard to test the business logic without also going through the UI and having this database in place. It's hard to test the database layer without going through the web UI because they're so tangled together. You want to be able to separate them enough that each can be targeted with tests on its own to really test out that side without testing everything else. Because if we've got to test everything together, it kind of defeats the purpose of unit testing and testing small pieces, because we can't do it. To test one thing, we have to test the whole system. And it also makes it very difficult to, in a fine-grained way, test the different pieces of it, because the only way you can get to them is through tangled paths in code, and you can't give them really, set them up with very clear tests to test them out. So ladies and gentlemen, you need to have a separation of code in your program. Interface-based program where you put in place very well-defined interfaces between things. And indeed, this is one of the big motivations for something like microservices or service-oriented architectures. It's the ability to target particular things for testing and to use them for many other pieces. Put another comment in there for specifications. You want to have in place, wherever possible, documentation on what some code does, even if, and typically it doesn't provide information on all the details of the how. That's the internal code. But you need to have some sense of what this does so you can be a meaningful client. You need to know what this accomplishes so I can figure out, does it meet my needs, know how to call it, and I'm confident of what will be guaranteed going forward. That even if the code base evolves, these things are guaranteed. They're laid out as guaranteed. If I'm just testing code, I don't know what's guaranteed. Maybe it will be changed later for a different algorithm. And then my code will break because it's using it. Maybe right now it doesn't handle null pointers, but later it will, or vice versa it works, right? I can pass this thing and it's null, and everything works just fine, but maybe later it'll cause it to blow up. You want a specification of the interface, if possible, that basically says what this code does, what it needs as inputs, what it accomplishes, what it returns, what it modifies in terms of system state. These are called specifications, and they're also best practice, and they go along with interface-based programming. You specify the interfaces, and then people or clients of this interface know how to call them. Okay? Ladies and gentlemen, I am looking to you for those. Now there's this term test hook, which we'll be talking about later in the semester. But the idea with a test hook is, ladies and gentlemen, often pieces of the program contain interfaces or pieces of interfaces that are not merely aimed at the clients for those interfaces, the people who use them elsewhere in the program. They're aimed at testers. Test hooks are designed to explicitly confirm the functionality and that the workings are correct of this system component. So maybe it checks the consistency of a data structure. Maybe it simulates an error condition, like, okay, essentially pretend there's no network connection now, or pretend there's high network congestion. So you put in place high latency responses so that timeouts can occur. You simulate a out of disk space error condition. You simulate an error condition where you're out of memory. Does the program behave gracefully as a result? Or you ask this data structure to check particular things. Make sure there's no duplicates in it, for example. Make sure that there's no null pointers in here for keys or for values in this data structure. Test hooks are designed to support testing. They're hooks into this little area that allow you to check, is it working properly? Is it operating correctly? Sometimes you have algorithms that are fairly complex and they accumulate some information needed to make sure, yes, it's working, it's plausible that it's working. I also want to see assertions in place. I spoke about that before. Assert early, assert often. I'd like to see assertions for the preconditions and postconditions that are stated by specifications, but also just for programmer assumptions. Whenever you think about what can I assume here, document it with an assertion. They're almost self-documenting code if used right. They help the code say, this is what I'm assuming. And I might add that, well put, tests also serve as code documentation. Okay? Spoken about test-driven development. Unit testing I expect to go on from developers. I expect as part of TDD that developers will put in place unit tests. And I would like to see, it's actually not required, but I would like to see use of mocking. What is mocking? Yeah.
Making fake objects just to test features.
That's right. That's right. Back when I wore a young man's shoes, this used to be called stubbing, putting in place stub code. And the idea was, ladies and gentlemen, that you put in place a fake version of an object, often it is, or of a Go interface or what have you. Sometimes before the real one's available, so you have kind of there's a very interesting development methodology called tracer bullets, which if you look at, which is all about providing stub versions of things or fake versions of things or mock versions of things, choose your language, before the actual ones are available. And then you go through and those all adhere to the same interface, and then you just go through and you change the implementations. It's worth looking at if you haven't seen it. But it's not always a matter you put them in place first. Why would you put in place a mock if the code was already written? So here you have code for this component. Maybe it's an object. Maybe it's a couple objects working together. Why would you put in place a mock if that code is already written?
So that you can test things that are always there individually.
Okay, that is the key thing. I heard two key components there, so that you can test things individually. Ladies and gentlemen, we often have a situation where we have a component we want to test. I'm not making a political statement with that, but I'm just imagining a situation where A tests B, C, and D, right? And And we would like to test A. And if you ever wondered, okay, if I have a class and it calls off to, class B, C, and D, maybe in 270 you learned about the idea of cohesion and loose coupling. That within a class you should be testing using lots of its methods in a consistent way, and then it should be loosely coupled to other classes. It can be calling off to other classes, but it shouldn't be interwoven with it. But very commonly we do have a class A calling off to a couple other components, right? And it's very common. And if you've ever wondered, how do I test A without also getting all entangled with testing B, C, and D? And then maybe, I'm simplifying it here, but maybe each of them, depend on other things, right? Maybe C also uses D, and it also depends on E and F, which use each other. And now it almost seems like to test one, I'm testing everything, which is not what you want. You sometimes will with system tests. That's the job of system tests, is to test the whole system working together. But what you'd like to be able to do is have a way of focusing in on A's functionality itself. And so what you do is you create a mock. You create mocks here. So you might create a mock for M, a mock for C, and a mock for D. And instead of A using the real classes, it uses these mocks. And these mocks are set up to do particularly simple things, like they return fixed values or random values within certain ranges. They'll test. Now, this is the difference between mocks and fakes. With fakes, they'll often do those simple things. But with mocks, we often have them testing things like, is the call to me meaningful? This thing should only be called once, because it's an initialization thing. Is it only being called once? Is this parameter being passed within a reasonable range? Is it non-null, on a consistent basis? But they return back information here. And these mocks basically allow you to test A without all testing the others. And the beautiful thing, ladies and gentlemen, is that there's quite a few frameworks out there. JMock, Mockito. There's JSmock for JavaScript and so on, that allow you to create mocks very easily. And some of them allow you to declaratively create mocks of certain interfaces or classes. What do I mean by declaratively? Well, you just specify what you want, and it takes care of the how. A little bit like Prolog without cut. Do you remember, do you folks take 340? Maybe you're taking it now, some of you? Some of you already took it. Okay, so in 340, I think there's a notion they talk about of declarative languages. Maybe that term isn't used. Maybe it was a long time ago. Ladies and gentlemen, the idea with the declarative interfaces, you'd say, okay, I have this interface, I have this class, I want to create a mock of it, go do it. And it would create a mock, it would have all the same methods, same name, same basic way of dealing with it, and then you could call that mock, and it will pretend as if it's the original class, but you actually specified, like, let this method return these random numbers, let this method test the values of the calls, let this method make sure it's never called more than once, or what have you. And it makes it happen. So mocking is something that allows you to focus in on certain subpieces to test it. It allows you to focus in a way that allows you to check whether certain preconditions are being met, etc. And allows you to fundamentally test things more independently. It's not perfect. There's some work involved. I don't require that all teams use it, but I sure as heck admire the teams that do, because it's a widely used practice in industry to allow us to test things in an independent way, which simplifies our life as far as testers. Maybe D or maybe F use the database. And when we test this, we don't want to have to set up a whole stinking database just to test A. Maybe B outputs things to the screen, and we don't want to have our test interface with, output visually and so on. Maybe other things send email. Maybe C sends email, and we don't want to be testing A and have it be flinging emails around. So we can test A in its own focused way without testing it entangled with everything else. Does that make sense? Okay, you can go read about Monking, go read about these frameworks. And ladies and gentlemen, some of the newer advances in languages and so on make it particularly easy to do mocking. And, for example, components of the Scala Play framework for web development support nice mocking, they support really nice testing interfaces, etc. So there's been a lot of push in recent years to provide support for effective testing with a lot of platforms, with a few grim exceptions, like Unity. Okay, ladies and gentlemen, I'm further expecting a few test matrices. So the basic deal with test matrices, there's nothing too fancy here. Ladies and gentlemen, it's all about coordination. It's all about taking the limited efforts that are available for testing and using them judiciously, using them in intelligent ways, not squandering them. And with a test matrix, it's a simple idea, but applied, it's powerful. And the basic idea is here, we have vertically in columns, we have different test cases. Okay, here are different test cases. So test case 1, test case 2, test case 3. For some of our system, we have 900 test cases in place. For yours, I'd expect dozens. If you don't show me dozens of test cases, I won't be a happy camper. And I will mark with a sharp pen. Okay. So, ladies and gentlemen, these are the different test cases here. And what's on the rows actually differs from case to case. One version of this is different features of the system. And you indicate, okay, so this is feature 1, feature 2, and you indicate which test case tests which features. Or these may be different requirements, and you're asking which test case is testing different requirements. And by spotting things here, by spotting broad patterns here, you can often find ways to improve your testing. What would be two things that you might look for here when it comes to, let's suppose these are features or these are requirements? What would be something that would be worrisome? Yeah.
Test case that doesn't align with any of the features.
Yeah. So there's a test case and it doesn't seem to test any feature or any requirement. Why is that test case in there? Why are we running at every build, for example? Uselessly. Maybe it's an old deprecated thing that really doesn't have significance anymore. Get rid of it. What's another thing you might worry about? Yeah.
Feature or a requirement is not being tested.
That's right. So you have a feature and it's not being tested by a test case. That's a big concern. That's a vulnerability. How can you pass the red face test and say this is a well-tested system if there are some features which are never tested at all in any test case? Could you see why that might be a problem? Yeah. So, not too hard to produce. And frankly, I don't really care. I mean, if test cases could be in the rows and the other things on the columns, do it with features, do it with other aspects of functionality, do it with non-functional requirements. But what is clear is that you're using test cases and you're checking what test cases exercise, what they check. And you can spot big concerns. So I want to see test matrices. Yeah. I want to see both manual and automated testing. This is very important, ladies and gentlemen. I will not accept in this class a situation where all of your testing is manual. Amongst other things, will be inhumane. Be inhumane to your fellow students. Not least because there'd have to be a student assigned every build that takes place. Like something pokes them at 3 a.m. Someone's checked in some code. Time to run the smoke test. Bleary eyes, and, or mousing through the system. Looks good. Go back to sleep. No, you don't want that. Especially you don't want you to be that person who gets poked at 3 a.m. So ladies and gentlemen, you want to have some automated testing. And you should in fact have much automated testing. But mark my words, this automated testing should not be all purely through the UI. But some of it should be through the UI. UI tests are often system tests. They put the system through its paces with many features being tested at a given test. They simulate a use case, right? Where a user needs to do things. They open this, they undertake this action and get this result, and it checks those things. And it's operating through the UI. Maybe it's a web browser with Selenium, right? Maybe it's a desktop application with JRobot. There's platforms for testing effectively through UI on Android, and there's components of Xcode for doing it on iOS. Do some testing automated through the UI, and do some not through the UI. I mean, your unit tests should be automated to run the test harnesses, not through the UI. Your sort of low-level system tests and integration tests that maybe test a couple things together, those should be automated. You should be able to fire them up from a test harness and have them run and confirm results. Those aren't through the UI. So some automated tests are through UI, some are not. And I want to see both. You'll have fallen short of exploring the system unless you have both types. But more than that, I want to see manual testing. Should not be exclusively manual. Be both inhumane and ineffective. There are some things that are just great for automated testing. Giving the system random cases and seeing how it does. Running through whole sets of regression tests. Boom. In order to test out the system is still operating after these latest extensions. All these things still pass. Were you introduced to regression tests? Yeah? Okay. 270? 280? Or sorry, 370?
So much 370. It was mostly the development part.
Okay.
So 270 to it.
Okay. That's good. So those can be done automated. And indeed, I mean, much of what goes on when you do a build is you run this whole set of tests. Make sure it still hangs together, right? But ladies and gentlemen, beyond that, there should be manual testing. Manual testing that you do. Why manual testing? Why do some testing by hand?
If you've missed something with your automatic tests, it should hopefully be obvious to your eyes.
Exactly. That's one part of it. And often that will be the case. Why? What are some things people can pick up that the system is not going to pick up automatically?
How easy it is to use some functionality.
Good.
The button is too small or way too big.
Usability. I love it.
Also, we can recognize patterns.
Patterns, yeah.
Other
Like, the last 3 times I've tested it, this has been kind of flaky, this area of it. It's like, it takes a long time to update the screen or something, and I don't see that immediately, or it seems like there's an inconsistency here in how it's showing that sometimes it shows it this way, sometimes it shows it that way. And you start to smell that, wait, something's not quite right with this. And often it stimulates ideas. You learn from it, and it stimulates ideas for further tests. And at a bug party, you say, hey, look at this. This is a flaky area. Let's focus on that for a bit. And then you start really pushing on the flakiness, and the cat is out of the bag. You find outright failures. So we're pretty good at spotting like long delays, and an automated test is typically not going to notice a long delay. I mean, not by notice, I mean it's not going to be conscious of it. It's not going to say something's wrong here. It didn't update in time unless you program it to do that. What it's typically going to be looking for is a certain response was calculated. So these things matter. Human experience matters a great deal. The user experience. So those are some reasons for human testing. Learning, because we notice patterns, yes. We notice non-functional requirements, delays, for example, associated with it, things that are user experience impairments. Manual testing is very good for that. Manual testing is often a backbone, and often we can put things through paces in an exploratory way, find issues that are then subject to automated testing, that are tested from then on. So we turn a failed case that led to a bug report into an automated test to confirm whether or not it's been fixed, and that can be run in a regression basis from then on. System tests. I'm asking you to undertake, and you can go find videos of me talking about this for past sessions of the class, and you're encouraged to do so. You can get in place, ladies and gentlemen. I want you to get in place coverage tests that will not merely provide coverage at a statement level, although I'd like you to do that. You may put in place cobertura, for example. I think Istanbul is another framework. There's quite a few of these frameworks out there that do coverage testing at the statement level. So they'll sort of test out your program and report, 78% of the program is reached or something like that. And that's important, not because they demonstrate that it's guaranteed to be correct, but if you have never reached that point at all in any test, that's an automated test, you worry about vulnerabilities. But more than that, I expect you to be able to create for me at a high level of your diagram, a high level diagram, some statement about what your test cases test. Show me the paths through the system that you've tested. Maybe these paths are between pages on a web app. Maybe they're screens on a mobile app. Maybe there's sets of functionality in an interactive system. You tested this feature, and then you test that feature. From there, you can go to here. You can click this and that setting dialog, and then this other thing. Finish it. I want to see kind of the coverage that you weaved your way through this. So, just a few additional comments. You should be debugging not just the system, not just the defects, but the process. What gave rise to this? Why didn't we see this earlier? What could have helped us avoid this in the future? You got to use the bug tracking system. There's just no ifs, ands, and buts about it. I'm not particular what it is. You want to use the GitHub one, you want to use Mozilla, you want to use Redmine or Jira. I'm fine with these. There's any number of those out there. But you want to have something that will keep track of the bugs, allow you to indicate severity and priority for them, indicate who's working on them, when it got reported and by whom, a description of the bug report. If you do this by email, you may learn one of the added meanings of that famous statement in King Lear from the jester. He said to the king, "That way lies madness." Do not go that way, ladies and gentlemen. Do not go that way. So have a bug tracking system in place. And you might use it also to track feature requests and feature plans, etc. Build for testability from the start. I talked about put in place logging frameworks. Please have in place logging. That helps testability big time. And I mentioned trace hooks. Make sure you test errors. Consider the risk. Consider where if it fails, it will imperil things, etc. Consider containerization. We talked about this a bit last time, just in response to a question. Ladies and gentlemen, today's continuous integration environments, things like GitHub, for example, put in place mechanisms for easily outputting Docker containers from the pipeline. And Docker containers are exquisite for putting in place mechanisms that are completely reproducible. You run this Docker container on any number of different systems, Mac OS, Linux, Windows. You'll have exactly the same experience, guaranteed. More to the point, or equally important, it is completely self-contained by default. So if you restart it, you're back to the exact same environment. So if you can reproduce a problem in that, you can demonstrate it to someone else. It's a completely sort of identical environment that you might have for production and testers, for example, or you might have amongst different testers. And it's completely resettable, so you don't have to worry, well, it happened the first time, but now it's not happening because something got changed, apparently. Consider containerization. I don't have time to go into it here, but think about that. You should be putting in place buddy testing or pair testing. These are very powerful at a testing level, just like pair programming is. And you should get in place bug parties as soon as possible, as soon as you start having significant amounts of code to test. Share knowledge among the testing team, share knowledge among the broader team about where the bugs are, will help you drive forward quality. Okay. Make sure the code is tested against the smoke test before check-in if possible, and unit test, do unit tests during the build. And make sure requirements are transmitted within the team, and make sure the testers start to or talk on an ongoing basis to developers. Plan the test environment. Often this is within Docker these days, or that's a really great one. You can reset the state completely in something like Docker, and you should create some criteria by which it's worth testers to get involved in testing this incremental release because it has sufficient quality. It's not the final deliverable yet, but it's worth that to focus on. Okay, time is up here. I had 2 slides left. I'll probably just